there was a time when we had AGI predictions every single day, so I like to address that based off of facts that are backed up by the knowledge that we got about how AI generally works. First of all, AGI predictions don't make sense at all. And here's why. When anyone makes a prediction, most probably he has some kind of reasoning behind this prediction. So let's say that I am predicting, for instance, that some team is gonna win the next match in football. Most probably, I have some kind of reasoning behind this prediction. For instance, maybe this team has a very good squad this year, or maybe this team has won 2 matches in a row, and so they have a high probability of winning the next match, and so on. At the end, my prediction might be wrong, and they might actually lose the match, but at the end of the day, at least I had a reasoning behind my prediction, as opposed to all the AGI predictions that we have seen, whether they are from a CEO of a major AI company or from a random dude on X. Now, let me tell you why I think they don't have a reasoning. When we say that we will achieve AGI, it means that we want to improve AI. So let's see what improving AI means exactly. We said that the way most AI systems work is by having some data and then forming a function. We can always replace forming a function by a model or an algorithm, okay? So we whether improve the data, okay, which is the first thing, the data, or we improve the models, so we can improve the model, or we can improve both, of course. And there's one more thing that we can work on, which is the application. And this is another layer that we can work on and improve, which is the application layer, which is usually the software or the program that you use to deal with the LLM, like Cloud Code or Codex. So to improve AI, we want to improve the data, or improve the model, or improve the application. Let's see them one by one. First, if we want to improve the data, we can do one of two things. First, we can generate new data, or we can squeeze the current data that we have. So we can generate a new data so that we can have a bigger data set overall, or we can squeeze the current data that we have so that we can get better results out of it. The first thing, which is generating new data, is so hard and actually near impossible. Why? Because those companies have fetched all the data that exists on the internet and they train the models on it. And so we don't have any more data left. So apparently we cannot get to AGI by generating new data, because as I said, it's too hard to come up with new data since they have used all the data. The other thing that we can do to improve AI using data is squeezing the current data that we have to get better results out of it. And I think they've been doing that for a while, but obviously this is not going to lead to AGI either. So it seems like improving the data is a dead end when it comes to AGI. So let's see the second point, which is the model. And also we can do one of two things here. We can come up with a new model, or squeeze the current models that we have. So we can actually come up with a new model, but here's what you need to understand about this. AI is a field that heavily relies on research, if anything. Unlike other fields like web development, for instance, when you use any tools in web development, most probably the people who build this tool are engineers or developers. Of course, web development has research, but the whole field doesn't depend on it as AI does. So it's a fact that AI relies on research, but what you need to know about research is that it takes time. And by time, I mean months and years, not days. We said earlier that the smart algorithm that people came up with was the transformers that came out in 2017, but the transformers didn't just happen out of the blue. It wasn't like someone woke up and said, hey, you know, man, I have this great architecture that we can use. It was based off of years of research before it, and this is what usually happens in research. Some people come up with a solution to a problem, and then some other people build on this solution to build a better solution, and so on. So the process takes time, and it's not predictable at all, no matter how much money you spend on it, because sometimes no matter how much money you have, it's not going to benefit you at all. You know, like, you cannot say, I want to run 10 kilometers in 1 second, even if you have billions of dollars, you know? So the research process takes time, and it's not predictable. You cannot bank on it. It might take weeks, it might take years, and it might take forever. So coming up with a new model is actually hard, as we see. If you want to do the second thing, which is squeezing the current models that we have, you can actually do that. For instance, the transformer consists of two main things, which are an encoder and a decoder. And the model GPT-1, which is one of the very first models of OpenAI, was just 12 decoders stacked, and GPT-2 was 48 decoders stacked, and GPT-3 was 96 decoders stacked. So we can go that way, and I also believe that this is what they have been doing for the last couple of years, but also clearly it's not going to lead to AGI. So also this path doesn't seem like a very clear path to AGI. And what even makes it harder is that we know for a fact that LLMs are not in any way going to lead to AGI. There are some very powerful tools, but they will not lead to AGI in the way we picture it. So also improving AI by building better models, I will not say that it's a dead end, but I'd say that it doesn't seem like achievable in the very near future. So the last thing that we can work on to improve AI is the application, and they have done a very good progress in this aspect, but clearly this as well isn't going to lead to AGI because the application always depends on the model itself, and the model depends on the data and so on. So this is everything that I had about AGI predictions, and let's cover another point.